Assalamu alaikum. Hope you all are fine. In this video, we will learn about the reactions of phenols. So, firstly, we will see the reaction between the halogens and the phenols, how they react, and the final product we get. So, basically, when we see the halogenation, that means the addition of halogens. That halogens are fluorine, chlorine, bromine, and iodine. So, firstly, when it react with the fluorine, it is a very rigorous reaction. It will be very fast, and it cannot be observed thoroughly. And when the phenol or other compound will react with the iodine, then the reaction is too slow, and it will take much time. So it will not be suitable for the observation. The bromine and chlorine are two atom molecules that is good for the observation and to conduct the reaction, that are bromine and chlorine. So basically, when the halogenation occurs between the phenol and halogen, so we will take bromine or chlorine because it is good to observe when these atoms or molecules react with each other. Firstly, the first compound is phenol, and it will react with bromine, and we have the final product, that is 2 or 4, means ortho or para position halogens attached on it. So basically, these are two kinds of products we get that are at ortho position, bromine or halogen attached, and or the on the para position, the halogens attached on the phenol. So basically, this will form a ortho or a para bromo phenol. And we have talked about the bromine molecule, that we have its limited amount, and when the we add more or unlimited amount or excess amount of halogens, and let it react with the phenol, so the final product will changes, as you can see in the second reaction between the phenol and the excess amount of halogen. We get 2 4 and 6 tribromophenol, and byproduct that will the when the bromine react with the phenol, and from the phenol, the carbon that has hydrogens attached to it, then these hydrogen will replace with the bromine, and then these hydrogen will attach with the bromine and forms a hydrogen halide. So these are the reactions of phenols and halogens. This is the reactivity, and these are the products of phenol when react with the halogens. So the other is the nitration. Nitrations mean the addition of nitro group. So we will take dilute HNO3 and at some temperature, that is 293 Kelvin, and let it react with the phenol. So the product we get is 2-nitrophenol, that is a major group, or we can say it orthonitrophenol, and the other is a minor product, that is 4-nitrophenol or para nitrophenol. So these are the products that forms after the nitration of phenol, and these are the product when the dilute HNO3 is added with on the phenol, and when we take excess or concentrated amount of acid, that is the final product will change, and the final product is, as you can see in the second reaction, the final product is 2 4 and 6 trinitrophenol, and the byproduct, that is water. So this is the nitration of phenol. And the other is the sulfonation reaction, in which the sulfuric acid is added, and we will see when the phenol react with the concentrated amount of sulfuric acid, and we provide certain temperature, and if we provide 25 degrees Celsius, that is a room temperature, to it, and it will convert into the major product that is under kinetic control. So at the room temperature, it forms a ortho sulfur at the ortho position. The sulfuric acid will react and attach on the ortho position at 25 degrees Celsius. And when we allow a high temperature to this reaction, the final product will change because of the changes in their temperature, in their conditions. So we get the para position compound, that is a major product under the thermodynamic control. And as you can see, when the conditions are different, the final product or major products are different. So as a result, the ortho and para products are formed and in the sulfonation. And in the nitrosation reaction, we will take phenol and nitro group that will attached on the para position, and on the para position the p nitro phenol nitrosophenol will form. So why we call it nitrosophenol? Basically the nitro will form two bonds or with the oxygen atom, and this will known as nitrosophenol. And after the tautomerization of the nitrosophenol, it will form uh, a quinone monoxime. And tautomerization is a process in which, or is a or is a process in which the molecule compound will remain same, because its molecular formula will remain same, but the arrangement of the atoms along the compound will be changed. As you can see in the nitrosophenol, p nitrosophenol, the nitro has nitrogen atom has two bonds with the oxygen in it. And as you can see, the phenol has hydroxyl group. So when the tautomerization occurs, it will rearrange, and the hydrogen from the hydroxyl group will forms a bond with the oxygen, and the nitrogen and oxygen bond will break. And when the nitrogen and oxygen bond will break, the carbon and nitrogen bond will be formed as a new pi bond between the nitrogen and carbon, because in the first compound p nitrosophenol, the carbon and nitrogen has only one sigma bond. So it will form a pi bond and a double bond after tautomerization. And this is a reversible reaction, a reversible product that will we have in the same time. This is the nitrosation. And the other is the reaction with sodium metal. So sodium metal when the reaction of sodium metal with the phenol, the product we get is a sodium phenoxide ion, that also when react with some acid convert into phenol itself. So basically when we take phenol and sodium metal, that is we add sodium molecule, we have a final product that is sodium phenoxide, because sodium in this reaction will act as a electrophile, and then these electrophile then target on the hydroxide ion on the phenol, and it will replace the hydrogen from the hydroxyl ion. And hydroxide ion then it will replace, and make a bond with the oxygen, and they will have the oxygen will get negative charge, and sodium will get positive charge. As it is in the hydroxyl group, the whole molecule or ion will have a negative charge on it. So basically, in the sodium phenoxide ion, oxygen will get negative and sodium will get positive charge, and the byproduct is hydrogen molecule. And the other is when we change the sodium, or as you can see in the first reaction, we only add the sodium molecule or atoms. In the other reaction, we add sodium hydroxide that acts as a base, and from this base, sodium will act sodium positive ion, that is a good electrophile, and it will replace the hydrogen from the hydroxide ion. And the final product we get the same as above, the sodium phenoxide, and along with the byproduct, that is water molecule. So the other is the carboxylation of phenols. So phenol, the carboxylation means the addition of carboxylic group, that is COOH. And when the phenol act with the sodium hydroxide that acts as a base, so sodium gets a positive charge and acts as an electrophile, and will break the bond between the oxygen and hydrogen on the phenol, and will replace the hydrogen and attach in place of hydrogen, and positive charge on sodium and negative charge on oxygen. So then the sodium phenoxide ion will form, and then this ion will react with the carbon dioxide, and this carbon dioxide will attach on the ortho position, and it is when it attach on the ortho position, it will forms a bond between carbon and carbon, and breaks the bond between carbon and hydrogen. So the product is a sodium salicylate, and we have sodium positive charge on the one oxygen of carbon dioxide. So when the proton is added on in this compound, the final product we get is the sodium. And when where the sodium ions that are positive ion will replace the hydrogen will replace the sodium ions, and will forms a bond with the oxygen that was attached with the sodium. So we will get the carboxylate ion, that is COOH, and the final product we get is a salicylic acid. So its IUPAC name is 2-hydroxybenzoic acid. So carboxylation of phenols means the addition of uh, carboxylic acid, or carboxylic group on the phenol. So the phenol will remain same, that the phenol has hydroxyl group, and along with the carboxylic is group will also attach on this phenol. So the final product is salicylic acid. This is the common name of 2-hydroxybenzoic acid. So these were the reactions of phenols with certain substances or compounds or molecules. So these were the reactions of phenols. Thank you so much. Take care. Allah Hafiz.